So, we're going to talk about one more concept before we go any further. And we're going to really explore this idea of parallel versus perpendicular lines and how to find the equations of them. We're going to also do this in the next video, probably 2 videos from now, when we talk about point slope form of a line that gives us a really, really succinct method on how to find equations, which is great. Right now is more of an exploration, like how do we go about, what does parallel mean, what's perpendicular mean, and how we find the equations of that with slope-intercept. So last little bit of slope-intercept, transition into this idea of point slope. We'll get to that in a little while. Now, if I had to tell you, if I had you show me, in other words, how parallel lines look, so what's parallel look like? You're probably going to hold up your hands and go, looks like this. Now, what parallel means is they never ever touch. So we couldn't do this, we couldn't do this. Those will eventually intersect one another. Parallel lines mean lines that never ever intersect. Ever. Like stairs. If staircases were to go up forever and ever, you don't want them touching because you start climbing and you go, oh crap, that sucks. Because they intersect. Your head would hit the top of them. We want stairs that go up at the same rate or down at the same rate. That's what parallel does for you. Parallel lines never intersect. And I also said something there. I said they go up or down at the same rate. Their rate of change is identical. Their slope is exactly the same. Their slopes are equal. So what I need you to know about parallel is that parallel lines never touch. More than that, the reason why they never touch is because they're climbing or falling at exactly the same rate. That means their slopes are exactly the same. Their slopes are equal. So when you hear the word parallel for lines, say parallel lines, the first thing that I want pop into your head is their slopes are equal. Now, perpendicular, that's a different word. So perpendicular obviously doesn't mean they don't intersect because those would be parallel. So perpendicular lines do intersect, but they intersect in a very special way. They intersect so that they create this right angle or this 90-degree angle. That's what perpendicular means. So perpendicular lines are lines that intersect at 90 degrees. Now, are they going to have the same slope? Well, that doesn't make sense because if they did, they'd be parallel. So they can't have the same slope. We already covered that. So they have to have different slopes, but the way those slopes are different is important. Now imagine this. If I tell you that this is one line, which would be a positive slope for you, and I say that something's perpendicular, it's not going to intersect it like this. It has to intersect at a 90-degree angle. So if one slope has a positive slope, one line has a positive slope, its perpendicular would have a negative slope. It would have to be an opposite slope. Let's suppose I have a downward line, a negative slope for you. Its perpendicular would be positive. So one thing I want you to discover about perpendicular is that the slopes of perpendicular lines will always be opposite. If one line has a positive slope, the perpendicular line has a negative slope. Always for perpendicular. But there's one more thing. It's not just that they're opposite. So if I give you a slope of positive 1/3, the perpendicular is not negative 1/3, not also shallow. The shallower one line becomes, the more steep its perpendicular becomes. The more steep one line becomes, the shallower its perpendicular becomes. That means that we have an inverse relationship or a reciprocal relationship. You put those two ideas together, and perpendicular lines have slopes that are opposite and reciprocals, or opposite reciprocals. They will have different signs, and their fractions will be flippy-dippy. They'll flip over. That's how perpendicular slopes work. Now, before we go any further, I gotta have you practice this. So let's check it out. Let's say I give you the slope 1/3, and I say, well, not parallel, that'd be easy. Parallel slope is just going to be 1/3. Parallel slopes are always equal. But I say I want the perpendicular slope. The perpendicular slope does two things. It changes the sign, whatever it is, it finds the opposite sign, and it reciprocates or flips over the fraction. So instead of having positive 1/3, the reciprocal would be 3/1. The opposite reciprocal would be negative 3/1. -3. You could simplify that to -3. That's the opposite reciprocal. Those two slopes are perpendicular, 100% guaranteed. If I did -5/7, the perpendicular slope to that, the opposite reciprocal, would reciprocate the slope and it would change the sign. So positive becomes negative, negative becomes positive, fraction reciprocates no matter what. That's the idea. How about one more? Just 2. How would you find the opposite reciprocal to 2? Well, the opposite part says I would change this to a negative, so positive 2 becomes negative something. But we also know that slopes are always fractions. So if you write that as a fraction, a slope of positive 2/1 is going to have a perpendicular to it of -1/2. That's how opposite reciprocals work. So when we talk about parallel, that's the easy one. Parallel, just keep the slope the same. Perpendicular, we're reciprocating the slope and we're changing the signs. And we talked about why. They have to be opposite reciprocals. So, whole little recap here. Parallel means they never touch, same slopes. That's it. Perpendicular means they're going to touch, they're going to intersect at a 90-degree angle, and their slopes are opposite reciprocals. We just talked about how to do that. So now we're going to move on a little bit. We only really get 2 examples here. I'm going to teach you how to find the equation of a line that's parallel to a given line or perpendicular to a given line. In order to do that, I got to have you realize one thing. There's only 2 things you need to know to find the equation of a line. You need a point, always, and you need the slope, always. So we're going to use these key words, this parallel, same slope, or perpendicular, opposite reciprocals, and we're going to find the slope that's given to you. So let's take a look at our equation. I want to find the equation of the line that's parallel to this guy, but also passes through that guy. There's 2 things we need. Number 1, look for a point. Have I given you a point? I always have to give you at least 1 point. So look for that first. Our point is blah, 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 passing through, my point. That's the point that we're going to be using. We will have to use that somewhere in our problem. We're going to be using that point. There's 2 things you need, a slope and a point. Find your point first. Now, next, in order to find the equation of a line, I also have to have a slope. Now, the slope you can get that one of 3 ways. Either it can be given to you, or you can be given 2 points and find the slope. Oh yeah, we've done that before, the slope formula. Or I can give you another equation and I can tell you, hey, from that equation, can you find the slope? Well, how about that? Could you find the slope of that? How's that written? Is that slope-intercept form or is that just standard form? Well, if it's not solved for y, that's standard form. But we've done a whole lot of work. Right now, I would encourage you to pause this or just do it as I'm doing it. Solve that for y. Because what we've learned in the last, I don't know how many videos is, in order to find the slope of a line, you either have to graph it, not fun. Look at intercept method, not fun. Those are fractions, not cool. And then find the slope from the graph, or you have to be able to solve it for y. That's the easier way. So let's go ahead, let's solve that for y. If we do, I know that we're going to be able to find the slope because we'll have this in slope-intercept form. If we get rid of our 2x, the entire term by subtraction, I'm left with positive 4y equals, keep that in order, negative 2x plus 5. But we're not done. Remember, solving for y is literally getting y by itself. In order to solve the rest of the way, we're going to have to divide every term by 4. If we simplify our fractions, and we do have to simplify our fractions, slope is a fraction, but it gets simplified. That's negative 1/2 x plus 5/4. Let me pause for just a moment because I'm about to say a big statement that I really want you to get. So, let's do a recap so you really get the next thing I'm talking about. There's 2 things you need to know to find the equation of a line. You need a point. It's always given. It's usually really easy to find. And you have to have the slope. That's sometimes not so easy to find. Sometimes I'll give it to you. Sometimes I'll give you 2 points. Or sometimes I'll give you an equation and a word. That equation, if you solve it for y, we talked a lot about it. If you solved it for y, it's very easy to find the slope. Right now, if you look at that, man, it should just be like a neon sign in your head. The slope is, it's this. I already know the slope. And then a word that relates your new line to the slope from your old line. I'll say that one more time. It relates your new line, what you want, from what you have. Now, here's the big statement. I could not care less about what that is. I don't care at all. That has nothing to do with what we're talking about. So all I'm getting out of this equation is a slope. That's it. Write it down right now. Your slope from that line. So we read it again. Find the equation of a line parallel to this one, passing through this one. I need 2 things for a line. A point, I've got it, and a slope. I've found a slope. Now comes your reading part. Man, half of getting stuff wrong is reading it wrong. I want something that is parallel. Please listen carefully. I want parallel to this. Now we know what parallel means. Parallel means the slopes are equal. So even though it's redundant, I want you to do something next. I want you to write out the 2 things that you need. Write out the point that you have. I'm given 1, 2. Write out the word that I'm relating the line you want to the line you're given. So write out that word, parallel. Parallel slope. That's what I want you to write out. So we've taken our equation. We've found the slope of the equation. It's -1/2. We've given a point. That's easy. We write it down. Now we look at that reference word, that relational word, that parallel word. You go, okay, I'm given this slope. Stick with me here. I'm given this slope. I want a line that's parallel with this line. I know that parallel lines have the same slope. So because this line has a slope of -1/2, every line that's parallel to it also has to have a slope of -1/2. Now, I've got a point and I've got a parallel slope. That key word is important. I'm going to start kind of having you think about the next thing I'm going to do. What if that wasn't parallel? What if that was perpendicular? Think about 2 things. If that word is perpendicular, would any of this change? No. Would this change? Absolutely. Think about how that changes before I get there in the next example. So we've gone through it. We now have a point. We have a parallel slope. Hey, let's try to fill that out. Let's try to fill this out with as much as we can. Now, I got 4 letters up there. I've got a Y, an M, an X, and a B. I have 3 numbers. Check this out. Don't get lost here, okay? This is the equation I want. I've got a Y, an M, an X, and a B. I have 4 letters. I've got 3 numbers. I know where that one goes. That's my M. Hey, could you fill out your M with -1/2? Absolutely. What are these 2 numbers? Well, that's a point. Every single point we have, every ordered pair starts with X and ends with Y. The only letter I don't have is B. Now, if you're wondering, where are you going with this? I'm going to use these 3 numbers. I'm going to plug it into the equation that has 4 letters. It's going to give me 1 letter at the very end that I don't know, my B. It's effectively going to let me solve for my y-intercept. That's impressive. So we can use the point you're given and the slope that you found to find the missing piece of your equation. So here's what we're going to do. I know that this right here, this is my X, this is my Y, this is my M. Let's plug it in. So I know that my Y is 2. Y is 2. I know that my M, I already have it. It's -1/2. I know that my X is 1. I know that my B is, I don't know what my B is. That's the whole point. In plugging in these 3 numbers, you allow yourself the ability to solve for the last one. That's pretty cool. So see if you can get that. I know my equation I want is here. I'm just I'm trying to fill it out right now. So I plug in my y value, I plug in my n value, I plug in my x value. It's going to allow me to solve for my b. So let's do that. Negative 1/2 times 1, well, that gives me negative 1/2. Notice how I'm using the point that I want my new equation to go through. It doesn't make sense to use this. That doesn't have anything to do with going through that point. So the whole idea is find your slope, use your reference word, it gives you a slope. I've already given you a point. Forget about all this crap. It doesn't matter. All I want is for this to create my new equation. So I'm plugging in my point that I want my equation to go through. That makes sense. I've got to have this equation go through the point, so use the point to make the equation. I want my equation to have this slope, so I'm using that. What I have to find is my y-intercept. So we do. Plug it in, find your b. If you add 1/2, you get 2.5. 2 plus 1/2 is 2.5. Now, if you want to write that as a mixed number, I don't really care. If you want to write this as an improper fraction, that's more of what you're going to see. So 2 and 1/2 is the same thing as, let's see, 2 times 2 is 4, plus 1 is 5. That's 5/2. And you know what? If you can do the next little step, you're done. Now, please don't lose me here. Please listen to this. We only used this point to be able to fill out this formula far enough so that we can solve for b. If you want to write the equation of the line, every one of our equations had a y and it had an x. We only used this y and this x to get us this far. To write the general equation for this line, we're going to go back to y and x. We're only going to fill out two numbers. The m, shouldn't be surprising, the m and the b. Excuse me. So we know what one point was. It allowed us to solve for our b, and now we translate this into our equation. I want my y, and I want my x. The only two numbers you have to put in now. Now that we had our m, we knew it from the beginning. As soon as we solved for this and we knew the word parallel, we had this. We used our point to find b. Now I want you to go back and fill out that formula again. Leave the y this time. Change your m into your slope. Leave the x this time, and then put whatever your b is. Positive b's get a plus, negative b's get a minus. And as soon as you do that, you have the equation of this line. You've got, oh, that's so cool. Check this stuff out. You've got an equation of a line that's parallel to this one. Verify that with me. Come on, stick with me here. If you solve this for your y, your slope's negative 1/2. If you look down here, your slope's negative 1/2. They have the same slope. They're both falling at the same rate. They are parallel. This one, I don't care what it was passing through. This line, the equation we found, it's parallel to this, same slopes, and it has to pass through this one. Let's check that. Because we used this point to create this equation, we would have to be able to plug in this point and it actually work. Let's just try it in our head. If I plug in 1, 2, 2 for my y and 1 for my x, remember this would be a 2. Plug in 1 here. Negative 1/2 times 1 is negative 1/2. Negative 1/2 plus 5/2. That's 4. That's 4/2. 4/2 is 2. This side gives you 2. This side is 2. I know that point is on that line. This is the equation of the line that's parallel to that one and has that as one of its points. That's what this does for you. That's kind of cool. I'm going to take a pause. I'm going to give you the other one, this perpendicular word. But before I do that, I want to preface the next section. The next little video we're going to do, it gives you a different way to go about this. Rather than explicitly solving for b, it gives you ability to do everything at once. It's more concise. It's called point slope. So this is one way to do it. It works well. I mean, obviously it works. But I'm going to give you a different way in just a little while that you don't have to solve for your b. So it does save a little bit of time. I just wanted to give this to you now. So we're going to take a moment. I'm going to ask you to do perpendicular. We're going to see how this stuff changes. As soon as I erase this and put the word perpendicular, we'll see what changes and what doesn't. I can't abbreviate like that. It looks too weird. So let's find the equation to this line that's perpendicular and still passes through that point. What's going to change and what's not? So let's walk through it. If I want something that's perpendicular to that line and passing through that point, I still need two things. I still need a point. I still need a slope. That's what we always have to find the equation of a line. So if you're ever asked, what do you need to find the equation of a line? It's a point and a slope. That's it. We're given a point. So we still have the same exact point. We still got that. Can you still solve this to find the slope? Yeah, this wouldn't change. So if you're asked for a perpendicular, you're still going to have to find the slope of whatever I give you. So it's still going to be -1/2. You still have to be given a point. We still have 1, 2. It's the reference word that's important here. That perpendicular tells you how your new line must be related to the line that I give you. So notice, if anybody's going to make a mistake, it's going to be doing this. It's going to be using the same slope when I'm asking you for a different slope. Parallel is pretty easy. Most students get parallel right because they go, just use that one. You're right, because it's equal. Perpendicular slopes are not equal. So that's one of those key words. When you're reading through the problem, if you read through and it says perpendicular, immediately in your head I want you thinking not the same slope. Opposite reciprocal slopes. So hopefully that's going to clue your mind into, yeah, I'd still solve it down. I'd still get the slope of the line I'm trying to be perpendicular to. I still have to do that. I still have the same point. I don't want to change that. It's this that's going to change. And this is why I wanted you to write the reference word, either parallel or perpendicular. As soon as you do that, ladies and gentlemen, I know it seems pedantic, like, why are you having me write out this stuff? Well, because psychologically, I'm trying to clue your mind into these little hints, these little triggers. So when you actively write down the word perpendicular, you're not going to make the mistake of putting parallel. Because if you write down perpendicular, it's going to clue your mind, it's going to trigger your mind to opposite reciprocal. That's what I'm trying to build in there. So find the equation perpendicular. Immediately I'm thinking opposite reciprocal. I still need a slope. I'm still given the point. I write down my point. It's still x comma y. Nothing's changed. My perpendicular slope, though, I wrote it down. It's clued my mind. It's triggered me. I go, okay, my original slope is -1/2. I am not going to write -1/2. That would give me parallel. We've already done it. I'm going to, okay, opposite, flip it, change the sign, becomes positive. So negative becomes positive, 1/2 becomes 2/1. Just 2. That's the only difference. Can you see how easy it is to make a mistake here? A lot of people, even though it says perpendicular, are going to use -1/2. If you do, it's going to give you exactly what we had before. That's not what I want. That's a parallel line. I want a perpendicular line. So what changes over here? Well, I still want the same equation. I still have exactly the same y. I still have exactly the same x. So we'd still set this up. We'd still have 3 numbers with 4 letters. The b's the only thing we wouldn't know. So 2 would be put in for my y. 1 would be put in for my x. But my m now, my new slope, my perpendicular slope is 2. That gives us 2. Oh, that's weird. Could you solve for b there? Looks like it. I mean, just subtract 2. Is it okay to get a b of 0? That just means that we're going through the origin. That's all that means. If we take our slope and our b, and we fill that formula out again, this time we leave our y, we leave our x. Our new slope is 2. Our new b is 0. I don't even have to put anything. Let's check our work. Is this line perpendicular to this one? That's how you check it. You go, hey, that slope is 2. That slope's -1/2. Reciprocate, change the sign. They have opposite reciprocal slopes. I know for a fact they're perpendicular. I've managed to create this according to the reference word, this relational word. So I know that I have perpendicular lines. Does it go through the point that I want? Check it. Plug in the numbers here. Plug in 1 for x, plug in 2 for y, and see if that point is on the line. If it is, you've definitely done it right. So perpendicular slope, check. Plug in 1, 2. 2 times 1 is equal to 2. 2 for our y. I know that we're right. That's the relationship between parallel and perpendicular. Parallel has equal slopes. Whatever you find, you use it. You always give it a point, and then we can find the equation. That's kind of cool. One thing, just make sure that, yes, you're using this point for x and y, but when you get down to your equation, you need an x and y. So this is only used to find the b value. That's it. After that, you put back your m and your b, and you're done. Perpendicular, slopes are opposite reciprocals. Just flip the fraction, change the sign, and do exactly the same thing. Watch the words, and you should be fine. Next time I'll see you, we'll talk about perpendicular and parallel in just a little while. Right now, I'm gonna introduce to you how you find the point slope formula. So we're gonna actually create it. I'll see you in the next video.